Ladies and gentlemen, it's an honor to be here as a guest speaker. And I would like to express my gratitude to Iqbal Academy for this opportunity. I understand that the topic of my talk today may be a bit heavier than you might expect, but I am prepared to put in some extra effort in order to make it as easy and simple as possible for me. Also, if there is something that you can ask me the question and I can then elaborate further at the end. So let's begin it with and I want to show you something of very importance, which is not directly relevant to the beginning of the lecture, but it will come later when deep, when we go deep down into the theory. So let me show you this thing. This is called the dichotomy of continuous and discrete. That is very important thing. Why? Because it is at the same time very deep philosophical concept. What is the dichotomy of discrete and continuous? And it is at the same time very deeply rooted concept in quantum physics. If you believe, for example, if you believe that the pattern of the universe is continuous, it necessitates that you believe in a universe which is eternal, has no beginning, has no end. And if you believe that the pattern of the universe is discrete, then it is a must that you consider your universe as it was started in the past someday and it will end someday. So that is why this concept, this idea of discrete and continuous is necessary. Also, it is rooted in quantum physics. Maybe you already are familiar with the concept of quanta, the concept of quantum, which is a discrete pattern, which suggests that universe has a discrete pattern and not the continuous one. So also Asherite's occasionalism is something which is of the quantum, which is related to the quantum. Almost 1100 years ago, I always call them the father of modern quantum physics, the Asherites. And I want somebody to write a research paper on this in this modern age on the necessity of Asherite's quantum. You can see in this slide, which I am presenting in front of you right now, that there is a picture of atom containing electronic shells. And they are called energy levels. So you can see that when an electron jumps from one energy level to the other, either it emits a photon or it absorbs it. For example, if an electron is jumping from the higher energy level to the lower one, so it will then emit a photon and we see light. And if an electron is jumping from the lower energy level, which is sometimes called ground state, and it goes upwards, it is gaining energy from somewhere, and actually it is absorbing a photon from the outer world. When it absorbs a photon, it depends upon the energy of the photon, that how much energy was in that photon. If the photon was a blue photon, meaning the energy was very enormous, and if the photon was a yellow photon or red photon, meaning the energy was very small, so accordingly electron jumps. If it absorbed a high amount of energy, then it jumps to some very high level of shell or energy level, or it absorbed only a small amount of energy, then it jumps to a very near one, the near level of electron energy levels. What does this mean and why this is related to our lecture? Because at the end, when I will present some of the Asherian thoughts in front of you, I will bring it back. And at that time, you will understand that why I brought it up in the beginning. So that was a necessary thing, and we are going to elaborate it when we'll talk about the discreteness and the continuous universe. So let's begin now with Einstein's space-time. As you can see in the slide, that this is space-time and not the space and time. That's something very necessary for Einstein's space-time, because Einstein claims that space and time are not two different entities. They are not isolated from each other. They are actually a single thing. This is us. We say space is something different from the time, but we cannot even separate when from where. It is not possible that you give somebody a time of meeting and tell him some place or space that he should come there and not give him the time. It is impossible. When and where are always attached to each other. If you give somebody a place, you must give them time. And if you give them time, you must give them the space. So that is how Einstein, not this is just analogy, not this is the mathematics. So Einstein correlate them mathematically. And what Einstein says is that space-time is a four-dimensional continuum, and time is the fourth coordinate of that continuum. So Einstein believes, as I expect you already know, the time is relative. Space-time is a relative quantity. It depends upon the observer's speed, and observer's gravity tells you what is time and what is space. For every observer it is different. An observer who is moving, the unit lengths of his clocks on the unit lengths of his seconds on his clocks, and the meter sticks he carries, they are different from a person who is standing still. And the meter sticks of a person who is standing still is different than the meter stick of a person who is moving. And the units length of a second of a person who is moving is different than of the person who is standing still. But this is called relativity. And before Einstein, it wasn't believed that relativity is a true thing. The absolute time was believed by scientists and by everybody. Before Einstein, they said the time and space are absolute. And even there was a debate between philosopher Leibniz and Sir Isaac Newton. This is a very historical, famous debate. They debated on the topic that either the time is relative or absolute. Newton believed that time is absolute. There is some sort of cosmic clock in the universe, setting time for everybody. Unit length of that clock will be the unit length of everybody's clock. If somebody is moving or standing, the unit length of the second of that person is the same as the cosmic clock suggests for everybody. So that is Newton's time, which is absolute. And also, Newton believes that space is absolute. What does this mean? It means that, as Iqbal analogizes it, and he says that Newton says, when you take out all of the content, all of the matter out the universe will stay there still. You take out the matter, but universe will stay still there as an empty bowl. And that is something Iqbal analogizes it as an empty bowl. But on the other hand, Leibniz was of the view that time and space are relative. He said that it is actually matter that expands space. Wherever you see far, far away that there is universe expanded or extended to that place, but that's not the universe. That's the matter went there. If you grab back that matter, if you pull back that matter into some single point, then all the space will be grabbed back and squeezed in that single point. It will be crunched back. So this is what even Newton presented an experiment which is called the bucket experiment, which is very famous. I'm not going to elaborate or explain it further because it will eat up my time. But bucket experiment, you should, if you want to study the bucket experiment, I have written an article already a few years back, and it's on social media on the bucket experiment. That is a very interesting experiment. And that proves, apparently, Newton successfully demonstrated that space is absolute by this bucket experiment. But he was wrong. Later we found that. Now, first question I want to ask you, that why Iqbal talks about time all the time? What is this time for Iqbal? Why in his everything time comes all the time? And you might answer that that's what philosophers do. They talk about time. That's their habit, but that would not be totally true. Some philosophers even don't discuss time. It's not necessary for every philosopher. And if some philosopher is discussing time, meaning time is his field, or maybe it is related to somehow its field. But Iqbal's case is different. As we know, that Iqbal is interested in time because of his concept of God. Because Kulla Yomin Huwa Fi Shan gives Iqbal a new concept of God, and then following that concept, he creates his own theory of time, which is very interesting. We will come to that later. So let me give you a hint that how Iqbal actually constructed his time theory, because it is necessary. Because if he objects or criticizes Einstein, then there must be some his own theory, some of his own ideas about the time. So how he developed those ideas out of the concept of God. Let me give you some glimpse. But first, think about Iqbal's determinism and free will concepts. Every philosopher who is interested in determinism and free will, each of them must discuss time, because time, if you believe that time is some sort of road, for example, if you believe that time is some sort of tunnel, then it is a must that you are walking into the tunnel, that you are walking on the road, and you are going towards some milestone of your life or some milestone in the future. That milestone is already fixed. You are going there. You just reach out your own life events which are laid for you in the future. But if you believe that time is some sort of experience, time is some sort of experience that you experience somehow, and it is not totally an objective thing, it is some emergent property of your own efficient self, or of your own, as Iqbal would say, appreciative self, then that experience of time is not what you think like a road. You already know that there are two theories, everybody knows that there are intuitively two theories of time. One suggests that time is a road or tunnel, another suggests that time is a river. You are some sort of a pebble sitting at the bottom of the river, and time is flowing over your heads. So these two things are exactly opposite to each other. If the time is river, then as Heraclitus said, that nobody can step in a river twice, because when you step once, river flows and goes on, and it went forever. The new water is new river. So this is called constant change, as you already know that Iqbal says that सकू महाल है कुदरत के कारखाने में, सबात एक तगय्युर को है ज़मान. This is constant change. But the second one idea, which is Einstein's idea, the time is a fixed tunnel. Time is a fixed road. You are walking on that road, and then you will reach out someday your future events. But before I go further, as I told you that I am giving you a glimpse of Iqbal's times theory. Why Iqbal wanted to believe in such time, which is very different than of the time of Einstein, than of the time of even Bergson. Some people say that Iqbal followed Bergson for time theory, but that is not true. He actually opposed Bergson on the time theory. So I'll come to that later. But what is his theory, and what is the reason behind his theory? What is the background of Iqbal's time? So let me show you that. You ask a question that what differentiates humans from animals? And this is a very common question in philosophy. Everybody asks this question. What differentiates humans from animals? One perspective is that of Aristotle. Man is a social animal. But upon further observation, it is clear that many animals exhibit social behavior, like lions, like wolves, like or dolphins, even ants. Ants are social examples of social animal. Another perspective, some medieval logicians told us that the differentiating element, the identifying element of humans from the animals is that they speak. They speak verbally in their communities, and animals don't do that. Okay? But then again, there are observations, scientific studies, even papers suggesting that animals speak. Some dogs bark words. Even some animals communicate in their communities. Some birds communicate in their communities. There is a bird I have heard about that bird. The 25,000 words that bird exchanges inside his community. They are almost the words of Firozul Lughat, 25,000 words. So that's not again the difference. Then some philosophers believe that this is the decision making ability that human has. They make decisions, but I think that that's not also true. Animals also make decisions. We just attribute their decisions to their intuitions. For example, you imagine a deer running through a jungle, and suddenly then he suddenly stops just because some sort of violent smell or scent hits his nostrils and he stops. And then he thinks not to go further because maybe there's some predator in front, in the front, on the road. So he changes his path, he changes his track, and that's a decision. That's not impulse. That's not reflex action. That's clearly a conscious decision. So what's left then? What is the difference between humans and animals? Only one question that satisfies me ever, and that question is coming from the philosophy of existentialism. Existentialist, as you have heard about the person called John Paul Sartre, existentialism asserts that the defining characteristic of humans is their distinct existence. They say that the human's existence precedes their essence. For all other things, including animals, essence precedes the existence, but not for humans, only humans. And that was the reason when abortion was uh, firstly by law forbidden, because then they believed that yes, human's existence comes first, then its essence. For example, for all other things, when you say that essence precedes existence for all other things, how that happens? Let me show you. For example, this chair or this dice or this table, they have their essence before their existence. You can imagine a table, a newborn, uncreated, unborn new table. You can imagine it in your mind. It's not yet existed. But that table, as soon as you imagine it, you immediately know the purpose of that table. What is the purpose of that table? What is the essence of that table? Similarly, all living things, such as animals, know their purpose from birth. And then they follow a pattern throughout their lives, a set pattern, a repetitive predictability. They follow it throughout their lives. So it is clear that this is human's existence that is different, in fact. You can imagine a duckling, you can imagine a baby chicken. As soon as a baby chicken is born, as soon as a baby chicken exits his egg shell, he knows that sound of predator, he knows that shrill, he knows that meow, and then he runs toward his mommy to take shelter under her feet, under her wings. And then you can imagine a duckling. As soon as a duckling is born, he can run towards water, he can jump into a pond because he knows how to swim. And only a human baby knows absolutely nothing except this one single ability of learning everything from the scratch. He is ready to learn, but he hasn't anything written on his slate, as philosophers call it, tabula rasa, a blank slate. Also, there is a hadith suggesting this reality. Kullu mawludin yulidu ala fitra. Wa abawahu yuhawwidanuhu wa yunassiranuhu wa yumajjisanuhu. Every child is born on fitra. And fitra here is clearly, here fitra is clean slate, because the rest of the hadith is, the context of the hadith is suggesting that. And also Iqbal believes this. As you have heard about Iqbal's freedom and free will, when he says, "तू अपनी सरनविश्त अब अपने कलम से लिख, खाली रखी है खामा हक ने तेरी जबी." So that's khali jabi is a tabula rasa, is a blank slate. So this is what makes humans different. This is what makes humans unique. But still, there is something to it. Can we call everybody unique? All humans are unique. Maybe some humans are following so very repetitive patterns in their lives till their death. Then they are doing so as similar as to the plants and animals and all, even to the like planets. So should we call them unique? Of course not. They are yet unaware of their existence as humans. So that's what differentiates humans from animals. Only that human is only that human is unique. Only that human is unique who knows he's unique. This is what I wanted to tell you about Iqbal's time. It will come later what the relation of this thing is with Iqbal's time. So only that human is who realizes that he was born without an essence, who realizes that he will have to actively define himself, who he is. That human is unique. So there is a Greek aphorism, know thyself. Also there is a hadith, man arafa nafsuhu faqad arafa rabbuhu. And that suggests that know thyself or explore yourself, who you are, and then you know that what is your specialty, than of the specialties of repeated patterns or predictability. So next slide, I'm giving you something very interesting here, because they say, the existentialists say, that every human can become unique just when he struggles or fights against those patterns, those fixed, predictable patterns of their lives. And when they do that, when this time comes in their life that they feel absurdity, they feel some uncomfortability by staying inside those repeated patterns. There are times when a person feels uncomfortable, and that is Iqbal, what Iqbal says, a great wealth. That uncomfortability, according to Iqbal, is a power of ishq. When you are inside the patterns and you feel uncomfortable in those patterns, that is what Iqbal called mataye bebaha. Mataye bebaha hai sozo saze arzu mandi. Maqame bandagi de karna lushane khudawandi. That's the uncomfortability, sozo saz. So that uncomfortability sometimes creates absurdity, which is very special term. Existentialists coined this term absurdity in a very unique way, in a very special way. This absurdity was firstly identified by and observed by French philosophers, and it created a new form of theater known as the theater of the absurd. This genre emerged in 1950s, and maybe some of you have heard about a novel which is called Waiting for Godot. That novel is also a play, actually, and that play is the same play played by the theater of absurd. So what I am going to suggest here That absurdity is because of the repeated patterns, and on repeated patterns Iqbal talk about just for the sake of his time theory. Let me show you here. Iqbal quotes Hobbes on the repeated patterns. Hobbes is a philosopher. Iqbal quotes him and says, to have a succession of identical thoughts and feelings is to have no thoughts and feelings at all. That's amazing. Repeated patterns mean you are living thousands of years in a single day. Maybe repeated patterns are the same. So that doesn't matter what your life is. If it is 1,000 years old, the age you get. But if you are living a repeated patterns life, meaning you are living a single day. So, but Nietzsche on the other hand, Nietzsche is very strict. Nietzsche takes it very seriously. Patterns for Nietzsche are serious matter of concern. He gets absurd by patterns. And he really, really absurd. His absurdity makes him build a new theory of determinism, which is this, in Iqbal words, a chronic, in Iqbal words, a more rigid theory, a more chronic theory of what you call determinism. Nietzsche says, Iqbal quotes him, Nietzsche says, fellow man, your whole life, like a sand glass, will always be reversed and will ever run out again. The ring in which you are but a grain will glitter afresh. So, and Nietzsche's free will doesn't exist. Nietzsche says the free will is a fiction. Nietzsche, in own Nietzsche's word, free will is a mythical fiction created by religious and moral authorities and systems to control individuals in order to hold them accountable for their actions. Nietzsche says that this is a myth. Nobody is free to choose, free for free choices, as all actions are already determined by underlying causes and motives. That is Nietzsche. And Iqbal says it the more rigid kind of the determinism. But my point is, here I am showing you a slide which is created by an artist who is demonstrating through this slide that Bergson ruins Einstein's Nobel Prize. Why? Why I am presenting this slide here? Because the question of determinism and free will was brought up here in this debate. This is a very famous debate, a historical one. In my words, if you ask me, I would say that the greatest historical debate ever on the nature of time. Although I have given you another debate between Leibniz and Newton, but that is not of this sort. This is a great debate, historical. It was held in Paris on April 6, 1922. Both of the great philosophers, great minds, Henry Bergson and Einstein. This debate was between Henry Bergson and Einstein on the nature of time. Henry Bergson proposed that there are two types of time: objective time and subjective time. Objective time is what we call serial time. Objective time is what we measure using clocks. We measure it using calendars. But he proposed that the subjective time, which he called duration, is some sort of inner experience, is an experience through our inner consciousness. And he called it duration, or a lived time. And he also proposed that time dominates self. He also proposed that there is no simultaneity in the universe. He says that simultaneity is immeasurable. You cannot measure simultaneity. Means two events are occurring at the same time. That is simultaneity, which was presented by Einstein in his theory. So he says Bergson was actually opposing Einstein's theory. And after 4 months, after this debate, 4 months later, Nobel Prize Committee asked Henry Bergson to recommend Nobel Prize for Einstein. He rejected his Nobel Prize on the time theory. He said, give him Nobel Prize whatsoever you want on the topic. So not on the time. He doesn't deserve it. His time theory is wrong. And he was a great philosopher. Henry Bergson himself was a great philosopher. Let me give you one example of his rock storic styles, uh, famous, and what you call it. He was like a rock star. When he went to America first time, New York was blocked. First time in the history, if you go and search on internet, first time in the history when New York was traffic jammed, that is the time when Bergson visited New York. So he was a very prestigious philosopher, and they asked him, should we give Einstein Nobel Prize on the topic of time? He said, no, his time is wrong, his time is not true. And that's why I put the heading here that Bergson ruins Einstein Nobel Prize. They gave Einstein Nobel Prize on another in another field called photoelectric effect, and Einstein got angry in his Nobel Prize speech. You can see that speech. He was angry. He never accepted that Nobel Prize. He delivered a speech on in the Nobel Prize on the Nobel Prize stage on the topic of time, and he insisted that my Nobel Prize is just because of my special relativity. But the interesting thing is, Iqbal took and showed very extraordinary interest in this debate, as it seems to be the case to me, because he didn't mention the debate in his book, but as he discusses both of them, Einstein's time and Henry Bergson's time, it clearly it shows that that debate when Iqbal was young almost. So in 1922, Iqbal took a very extraordinary interest in this debate. But he opposes Bergson on the self. He says it is not self that is dominated by time. Iqbal says it is time that is dominated by self. One difference, although he accepts the distinction, although he accepts two types of time from Bergson, the duration and the serial time. But as you know, the Bergson accepted serial time as the objective reality. Iqbal doesn't believe it. Iqbal says both of them are subjective realities. Iqbal says objective time is serial time is nothing. It's just an experience of our daily life self. He calls daily life self efficient self. This self is working self. This self is practical self in our daily life. So this is the experience of that self, meaning a subjective thing. And the second time, the duration he called the pure duration. He also differs in name. Bergson called it duration, but he called it a pure duration. Pure duration. So that the duration thing, he says, that is the experience of our appreciative self. He actually brings this self thing in his theory, and that is the difference from Bergson and Einstein's time. And I'm going to prove it that he was right against Bergson and against Einstein, but I am going to prove it on logical grounds, not that I love Iqbal, and you will see how. But Iqbal was very interested in this debate, and also Iqbal gave his own time theory just after this debate, when he very properly understood both of the theories of physics and the theory of the subjective theory of time. So efficient self, I have already talked about this slide. Next, about his appreciative self, let me show you Iqbal's own words on the appreciative self, because this is very important thing. This makes Iqbal. This makes Iqbal time very forceful in comparison with the Bergson time. This appreciative self thing, and this is coming just because he was a Muslim. So he says, if the life process of this deeper ego, this appreciative self, we call deeper ego, in the life process of this deeper ego, the states of consciousness melt into each other. The unity of the appreciative ego is like the unity of the germ, which the experiences of its individual ancestor exist, not as a plurality, but as a unity, which every experience permeates the whole. Iqbal talks about appreciative self and this idea of self all the time. This is actually his concept of God. This is coming from the Surah Ikhlas, but we'll talk about it later. Let me show you what differentiates Iqbal from Bergson. Let me give you some free style example. If you are inside a pattern, I'm asking you, if you are inside a pattern, what is a pattern, for example? A pattern is a repeated activity. A pattern means a repeated activity that is going on and on, like an hour clock of a clock, hour hand of a clock. So example is simple. If you are inside the pattern, meaning just go fly, jump and sit inside the hour clock, hour hand of clock, and then can you tell me where is the past and where is the future? Staying inside the pattern, nobody can tell you where where is the past, this side or that side, where is the future, this side or that side. This is something I am bringing up just because of the theory of entropy my daughter understands here. The entropy, the theory of the arrow of time, is the theory of the arrow of time, or the entropy tells you that when you are inside a pattern, you cannot differentiate past from future because patterns are alike. Okay, I give you more easier example. Just record a video of some repeated pattern. You know the video runs from past to future. Everybody knows that. Every video runs from past to future. Then bring that video into your computer and reverse it. And then run it. Can you tell the difference that video is running from the past? Simply that video is running from the future to past because you reversed it. But still, you are considering it is running from the past to future. That is the curse of pattern. When you are inside a pattern, you can never tell the difference. Either you are in past, going from past to future, or you are going from future to past. Anything, animals, humans, anything that live inside a pattern throughout their lives, they cannot differentiate. Either they are moving into the future. So patterns, this is the difference. Now I am going to show you on my next slide. This is the difference what makes Iqbal different from Bergson. Iqbal's theory of time doesn't follow patterns. Iqbal theory of time, if time is real and not mere repetition of homogeneous moments, which I am calling pattern all the time, if time is real and not mere repetition of homogeneous moments which makes conscious experience a delusion, every moment in the life of reality is original, giving birth to what is absolutely novel and unforeseeable. That two words, novel and unforeseeable, make Iqbal's time greater and more forceful than of the time of Bergson. Iqbal is saying this, every moment of Iqbal's theory of time is always new. Let me show you this is true. When Big Bang happened, the first moment started. And when inflation started, any new thing happened. The second moment came in. And any new thing happened. Now inflation got bigger. A new moment came in. And then any new thing happened. Like you say, the creation of the particles. That was a new moment. Then a new thing. Gravity came into the existence. Then a new thing. Every new moment is like kulla yawmin huwa fi shan. And that is what Iqbal is suggesting here, that entropy is already suggesting, which is a theory of physics. I am not bringing it up. Iqbal even didn't mention it. But entropy is already saying, you physics, students of physics know that time has an arrow only in one side, and every increasing entropy gives you a new creation, a new creative activity, and that is next moment from the previous one. This is the difference. This is the difference from the previous one, that the next moment is something creative. So this is Iqbal. But I will correlate with it Einstein's theory, and then you will understand why I brought these things up. Okay, so here I'm giving you Iqbal's humbleness. When Iqbal starts criticizing Einstein in his book, he prepares himself first. He apologizes in a style. And then he makes an excuse, maybe. I call it excuse or a confession. You call it confession, Iqbal is making here. Because he says that it is not possible for us laymen. First time I am looking at this word as layman Iqbal. Maybe Iqbal is a great man. How he calling himself a layman? So it is not possible for us laymen to understand what the real nature of Einstein time is, and it's Iqbal's greatness how he expresses his humbleness. But still, Iqbal's objection, as I will show you, is valid today on the theory of Einstein. How did he get his objection? While Iqbal doesn't know mathematics as much as Einstein mathematics is very difficult mathematics. It is called the most difficult thing, the mathematics of general relativity. And I am a teacher of physics and philosophy, and I have encountered in my life so many students that they are not afraid of anything mathematical, but only they are afraid of general theories mathematics. Why? Because it is a very difficult mathematics. And Einstein developed his theory and built his theory on his mathematics because of his mathematics. And how come that Iqbal objects it? Does Iqbal know the theory, the mathematics? No. Then why? How he got this courage to object Einstein without knowing the mathematics of theory? Just because Iqbal's objection is on the interpretation of the theory, not on the technicality of the theory. So this thing you should keep in your mind. There are interpretations and there are actual things. So for example, if there is a thing which is actual and which is mathematical, I am not able and I am not ready to criticize it. But if you interpret that thing in philosophical terms and you give me something wrong out of that, so then I will definitely criticize it. So that's what happened here. Iqbal criticized Einstein's interpretations by his interpreters, and he did not directly study Einstein from his books. So that is something which is not, I think, proper as a person who with the stature of Iqbal, because Iqbal studied Einstein from Einstein's interpreters and then criticized it. That's not a proper way. If you are going to study someone, and especially if you are going to criticize it later, then you must study directly. But luckily what Iqbal did was very perfect. Maybe he got some help, but Iqbal's objection is very valid and relevant today, till today. And now let me show you what Iqbal did. And here comes the technicality. I hope you are with me, because this technicality is something to grip, something to understand. So I hope you will stay with me on this. Iqbal tried to understand Einstein's theory through Ouspensky's principle. Ouspensky is a Russian writer. He is interpreter, Einstein's theory's interpreter. There are other interpreters. Iqbal got help from them, like Professor Whitehead and like John Wheeler. But this thing he got from Ouspensky. Ouspensky interpreted fourth dimension, Einstein's fourth dimension, in this way. Iqbal says a modern Russian writer Ouspensky, in his book called Tertium Organum, conceives the fourth dimension to be the movement of three-dimensional figure in a direction not contained in itself. Just as the movement of the point, the line, and the surface in a direction not contained in them gives us the ordinary three dimensions of space, in the same way the movement of the three-dimensional figure in a direction not contained in itself must give us the fourth dimension of space. This is the most difficult passage in Iqbal's book. The most difficult passage. I never met a person who understood it properly ever since 1998. This is the most difficult passage in Iqbal's book, The Reconstruction of Religious Thought. But let me show you step by step what does this mean. This is a point. Although I exaggerated it and now it looks like a square, but you inside your mind just consider it a point, a dot, a zero-dimensional object, because I exaggerated it just for you. So you imagine it as a point. Now this is a point, a zero-dimensional object, And what was the principle? The principle was, Ouspensky's principle was, find the direction that's not contained in the object you are examining. So now we are examining this point. And now our duty is to find the direction which this object does not contain. This object doesn't contain any direction. As we see, the point is zero dimensional. If a thing is one dimensional, then we know that there are two sides for one dimension, because one dimension is always a line. So we know that there are two sides to it. Line goes either the right way or the left way. So that there are two sides. But if a point which is a zero dimensional object, someone asks you what direction this object doesn't contain, how can you know? Because there is no direction in it. So it contains all direction. It contains no direction. And the next thing we are going to do is that direction we shall create forcefully, which it doesn't contain. Now we'll create a direction forcefully which this object doesn't contain. So this is the method. This is the method of Ouspensky's principle. How would you do that? Just in any direction, because it allows you all directions. Because it doesn't contain any direction, so you can do any direction. In any direction, just put a copy. Next step is find the direction that's not contained in the object you are examining, and then place a number of copies, the same object, in that particular direction. This will create a new dimension as well as new object. Let me show you this. I have put a copy of the same point just alongside the point, and that created a line. This is how Ouspensky interpreted Iqbal's, Einstein's fourth dimension, and not yet we have gone there, but we are going step by step there. So he said that a point doesn't contain any direction. You forcefully create a direction, but by just putting some number of copies, then you can create direction. So when you put more points, just the copies. So this was one, and this is next. So what this has become? This is a line. When you create more points alongside a point which was an initially zero dimensional object, you immediately see that the new dimension has become existent, and that new dimension is now a line. So principle will still stay, and this is interesting. The principle still stays. What principle is saying? That find the direction that this object doesn't contain. Now this is a second object, this is not a point. Now our duty is to find the direction that this object doesn't contain. Can you tell me that direction this object doesn't contain? Right and left are the same direction that it contains, because it's a line, and I have already told you that a line goes right or the left, or it is upside down, the line goes up or the down. But if line is right, left, what direction this line doesn't contain? As Iqbal is telling us, that find that direction, up and down, because this line is laying horizontally. So this, what direction this doesn't contain? And up and down. And now we forcefully create, just by putting the copies, that new direction. So let me show you how you put the copies. Okay. So the direction was not contained in that line. We forcefully created, by putting the copies, that new direction, and now we have another dimension. This is called a two-dimensional object. This object is a rectangle, or maybe a square, or maybe something else drawn on the board, because a two-dimensional object can only be drawn on a board or on a paper. This object cannot be drawn in three-dimensional space. So always you draw a point on a board, a line on a board, a two-dimensional object on a board, all two things you draw always on a board. You can never grab them out of the board and then lose them into the air, and you see now a point is floating, or maybe some line is floating. That's not possible. Always 1, 0, 1 and two-dimensional objects will stay on the board, on the two-dimensional surface. That's their ground. They stay on that surface. So principle will still stay, principle will still hold, and we shall follow that principle again. So what is next? I am asking you next again this question, that what direction this object doesn't contain. Now you can tell me that this object has 4 directions. It can extend itself to right side, to left side, to up side, to down side, but it cannot extend itself to the front or to the back. It cannot come out of the board. It cannot go inside the board because this would be the third direction. Now we forcefully want to create this direction. It's like just putting papers with alongside the other paper. It's an analogy. Paper is not a two-dimensional object. I'm just giving you an analogy. That imagine a paper is a two-dimensional object, and now put more papers with it. So in a direction, put those papers, and it will become a book. And that book is not designed on the board. That book is now in your hand. That book exists now in three-dimensional world. So that book is a 3D object. Let me show you. I am putting the same copy of the object as I told you, following the principle. So these copies are now making this thing. And this is what? A three-dimensional object. This is just drawing, but these chairs and these things, all of them are three-dimensional objects, and they are made just because of this method as we followed. So every three-dimensional object is in our 3D world, not written or designed or drawn on a board. We see it in front of us. This object exists in our room. We are ourselves a three-dimensional thing. Now, if you want to follow this is a very critical time. Now, in my talk, this is a very critical time. I need your attention more than ever. So, a three-dimensional object like a chair, like a book. If you want to follow still the principle, if you want to follow Ouspensky's principle now, what should be that direction which a three-dimensional object doesn't contain? A three-dimensional object like this dice, it doesn't contain, it contains all the directions. It can go upwards, it can extend towards right side, it can extend towards the left side. Anything that can extend towards sides is three-dimensional thing. So which direction we should look for? And let me give you a hint. If you see that there is no direction you can find, because all direction, this subject contains all the direction, and this subject doesn't contain any extra direction, because shush, jihad, front, back, up, down, right, left, shush, jihad, and 3 dimensions. This subject contains all the direction. So how would you put copies of this subject into a direction which this subject doesn't contain in it? That's almost impossible. So we imagine a scenario. We just create an empty direction, but we do not label it. We never assign a name to it. We just this is a dust trick, a mathematical trick. So we are following the principle of Ouspensky, and what we are doing, we are imagining an imaginary direction. This direction is not possible. This direction is not possible in our 3-dimensional world, because we see that chairs have all the direction. So how can we put the copies of the chair into a direction which it doesn't contain? It contains all the direction. How should we find that direction it doesn't contain? That's impossible. So we do a trick, and that trick we just imagine an empty direction. Just I put a line here with spaced, equally spaced marks, and I never put some names or labels on it. But let me tell you something. You say that right is side and left is its opposite side. You say that front is a side and back is its opposite side. You say that up is a side and down is its opposite side. So I am now asking you, past is a side and future is its opposite side. Past is this side and future is this side. So let me label it like the marks like 1 second, 2 second, 3 second, 4 second, the intervals of time in this direction. This direction, this object, this chair doesn't contain this direction, but I imagined it a new direction, a time-like direction, and gave names in form of intervals, first, second, third. So next, the principle we are following suggests that now put the copies in that direction, and this is where everything gets interested and everything gets Iqbalian. This is where everything gets Iqbalian. Now, the question is, following the principle, a very great interpreter of Einstein, the Ouspensky's principle, and now we see that we are putting, we want to put the copies in the direction of time, but how would you do that? If you are putting the copies, where you will get those copies? You know that this three-dimensional object is single one, and you want to put the copies of this object in some direction. Where are those other copies? That's impossible for you, and you must follow the principle. So let me show you how you do that. You put this object, as Einstein stated, and which is wrong, and as Iqbal objections will tell us, but just for the sake of Einstein's argument, look at here. You do not put the copy, you just pick your same copy and place it in the next second, and then pick the same copy and place in the third second, then pick the same copy and place it in the fourth second. So you are going towards future, and that's what Einstein suggests, that it's like putting the copies. You are in not any need of copies, just forward those copies in time, and that's where Iqbal apprehends him. If you are following some principle and then you break your own principle, that's not a valid philosophical thing to do. So let me show you what Iqbal says, but after 2 or 3 slides. Here in previous slide, I have shown you 2 space dimensions, x and y, and you can see that there is no z here, z direction, because we cannot create z direction if we want to create a t direction with it. That is almost impossible. That is critically impossible. You cannot do that. So I just imagined 2 space x and y directions, dimensions, and 1 for time. But this confuses me. This confuses me because it is just showing me that this object is moving in time. Yes, that's right. Objects move in time according to Einstein, not according to Iqbal. Objects move in time. We are all moving. Einstein just imagined a very simple thing. He says we are moving all the time into the time because we are going towards the future. Second by second we are going. We are time travelers. Everybody is time travel. Every object is time travel. Why? How do we travel into time? Because we go into the future. We are just time machines. We are going into the future. That's very simple, Einstein's theory, but that's what Iqbal differs with. Iqbal says that if you imagine things going through time, for 1 second, look at me. Einstein says that I am standing still, but I am moving through time, bit by bit. I am moving through time, and I am not standing still. You look at me, you say that he is standing still, but I am standing still only in 3D, which is 3 dimensions of space. But a 4th dimension also 4th dimension is a part of 4-dimensional continuum, which you call space-time. So I am still moving in another direction, as I showed you here. Okay, so that direction confuses me. Objects doesn't seem to move. Object looks like this. Object looks like this. Object is staying at some place. Like this object is here. This object is staying at some place, not moving in space, not moving in time. So let me put a clock on the right side as the direction. It is clock. It is a round shaped clock, not a line. But still imagine that now Einstein wants to say that object moves in time. Now you can imagine that yes, this object is moving in time because it is staying in space and time is passing over it. Okay, but this confuses me again. Why? Because Iqbal pointed out something very interesting. Iqbal says in the reconstruction, incommensurability, incommensurability, not common. And that's what many scientists asked at the time Einstein. Why this is incommensurability? Because this is the principle of physics, and there is a PhD student here, PhD doctor here of the physics sitting among us. You can ask him. This is the principle of physics, that you cannot equate 2 things without their units equation, without their dimensions. If you put something on the left side of an equation, and that thing's units are meters, You cannot put another thing on the left side of that equation whose units are seconds. That's not possible. That's called incommensurability. But as I will show you in a minute, in a second, that Einstein actually fixed, before Iqbal's objection, Einstein actually fixed this problem already. Let me show you here. Okay, let me show you first what Iqbal wrote about the incommensurability. He wrote, as a new dimension, this distance separating events in the order of succession is incommensurable with the dimensions of three-dimensional space. Yes, that's incommensurable. Yes, the units of three coordinates, like units of s coordinates, are meter. The units of y coordinates are meter. The units of z coordinates are meter. And the units of time coordinates are seconds. This is incommensurability. You cannot equate them. But actually, Einstein fixed this problem before even he presented his theory. Iqbal just didn't know. So let me show you that. Einstein put a c before t. And that's what makes it to change to meters. And that's what makes it even religious thing, because c is nur, c is speed of light, and c will do everything what Iqbal wants to do. At the end, I will show you in the last slides, this c will do some amazing things, some miraculous things. So for now, let me show you, but Einstein put a c in front of t. And how did this c make the same units? Let me show you. Now this is x are meters. Now v is a velocity, and I hope you know already that the velocity's units are meter per seconds, meters divided by seconds, and c is the velocity of light. So units should be meters per second. If this is velocity, the velocity is always meter per second. And then when you put c before t, it will change a little. It will do meter per second times second, and second will cut the second with it, and now ct is meters. So that's what Einstein did for equating his time coordinate with his space coordinates. And now just by putting c, now Einstein made possible a fourth dimensional object, made possible a four-dimensional object including the time coordinate same as the space coordinate. And that's where Iqbal's objection starts. Iqbal doesn't accept time as the space coordinate. Iqbal is very uncomfortable with this thing, because Iqbal loves time, but when you say the time is nothing, there was an x coordinate of space, there was a y coordinate of space, there was a z coordinate of space, and there was another coordinate of space, but that coordinate of space is t, maybe ct. Iqbal gets uncomfortable. Oh no, my time is going now becoming a space. My time is becoming space. That's unacceptable. So Iqbal writes about Einstein's fourth coordinate and says, this obviously means that what appears to us three-dimensional beings as time is in reality an imperfectly sensed space dimension, which in its own nature does not differ from the perfectly sensed dimensions of Euclidean space. In other words, time is not genuine creative movement, and that what we call future events are not fresh happenings, but things already given and located in an unknown space. Like I already given you a glimpse that time is a road according to Einstein, and there are milestones in future, and those milestones are your future. You just reach there. They are already existing things. If things are already existing for you in future, then what's the purpose of your life? How would you even define your actions? So that was something very uncomfortable for Iqbal, especially for a philosopher, not for a scientist. So he just clearly wrote in his book that this thing is unacceptable. Einstein proved mathematically that time is the dimension of space, but that is not still yet acceptable for me. And I will show you that Iqbal was right. Okay, now this is the time I will show you how Iqbal fixes Einstein's problem, where Asherian comes and where quantum comes. This brings up to the point where Iqbal fixes Einstein's philosophical problem. And I'm calling it philosophical with very cautious mind. This brings us here, where Einstein's philosophical problem Iqbal solves. Not because, of course, obviously, Iqbal can never mess with Einstein's mathematics. He even couldn't do it. So he doesn't touch the mathematics. He just solves a philosophical problem. And what's that problem is philosophical. Iqbal says it's not the object that exists in time and space. It's the time and space that exists with the object. And here I want you to stay with me. It's not the object that exists in time and space. It's the time and space that exist with the object. It's clearly a Sharian view. It's clearly a quantum view. Actually, what you see here, Iqbal is telling you that where are those copies, as I have shown you earlier, where are those copies that we've been putting onto each other when we were creating the fourth dimension? You say that somehow those copies are not there. You just say that somehow we don't need those copies. We just pick our one single copy and bring it up on the time direction. Iqbal says that's not what you should follow from the principle. So you must put the copies. And if there are multiple copies, increasingly multiple copies of the same object, where those copies have gone. And if Ouspensky's interpretation is true, then those copies should be there. And if you think that those copies are there, then there should be an enormously increasing mass, because every copy would have brought its mass onto the same object, and this enormously increasing mass will create some sort of explosion maybe for every object. That's not possible. So that's not the case. Only one option is left, and that option is the indication of Iqbal, the one philosopher in the world who indicated this thing for Einstein. And that is only one option. He says that somehow those copies are disappearing because this universe has a discrete pattern. And as Asharian suggested, that God created everything in such a manner that everything is infinitely, almost infinitely small. Asharian told us, Asharian wrote have so many books, there are so many philosophers, and their collective work Iqbal is mentioning. And Iqbal is mentioning with a very keen and deep interest in his book. And he's telling you this: as today's quantum physics believes that there is a Planckian length, you know that, 10 to the minus 34. As quantum physics believed that there is a Planckian length of space, Asharian believed that there is a Jauhar-e-Makan, same as small as a Planckian length. As today's quantum physics believed that there is a Planckian time, 10 to the minus 45. Same like them, 1100 years ago, Asharian put a Planckian time in their own words, Jauhar-e-Zaman, and as little and small as today's Planckian time is, and same as today's Planckian action. You know that the most important thing in Planck's and quantum theory is Planckian action, Planckian energy level. Same like that, Asharian 1100 years ago suggested that there is a Planckian act. And also they put something else which today's quantum physicists don't know. What? Planckian a quanta of rest, a quanta of motion, and there are some other quanta in Asharian theory. And then they say, and they are actually answering to the Zeno. And then they say, if you are standing on one point, and now you want to go to the next point. If this is a point, if that is a point, then in between those 2 points, where were you? Where you have been? If you are at first point on first moment of time, in first interval of time, you are at first point of space. Now on the second moment of time, on the second interval of time, you are on the second point. In between those 2 points, what's there? Asharian told us. Actually, Zeno's question was this. Zeno says that nobody can step over infinity because in between 2 points, from 1 to 2, there are infinite points. You already know that in mathematics. So, Zeno's objection was from 1 to the 2, you cannot ever go, therefore motion is impossible. But Asharian answered to them and they said no, division of infinitely small things is impossible. Layat jizaz is impossible. You just have to put some limit on those divisions, and that limit suggests a Planckian length, a Planckian time, a Planckian space, a Planckian motion, a Planckian action, a very 10 to the minus 34, 10 to the minus 45. This is the limit. They actually suggested this, the Asharians, and then they told us that when you are on a first point and you want to step towards the second point, in between those 2 points you weren't existing at all. God created you at first point, then you started, and then you disappeared, and then in a Planckian time, which is a very small time, nobody can see us disrupting the universe, us disconnecting our existence. Nobody can see the disconnection of the existence for anything, but it's still valid. Look at this mouse pointer. This mouse pointer is moving. You can see that this is motion, but everybody knows in their mind that this is not a motion. Actually, when the mouse pointers was here, some pixels got glowed. Maybe they some there was a glow. There was a whitish pixels here. So when you moved it, and they got dimmed, and the other pixels got glowed. So this looks like a motion. They say that actually when you are stepping from one point to the other, in between those 2 points, you weren't existing. God created you at the first point, then immediately God disappeared you. Then in a Planckian time length, the limit of Planckian time, you were again created by God. So this is how they interpreted their Inna Allah ala kulli shayin qadir ayah. This is Asharian view, but 1100 years later, quantum physics proved the same thing, as I have shown you a slide in the beginning. In that slide, you saw that when energy level of electron was a ground state, and when electron went towards the next and jumped towards the next level of energy in an atom, what you see that in between those two shells there were nothing. No electron exists in between those two shells. And whatsoever is making electrons bigger shells is light. So light is some sort of nur coming into the matter. Matter is absorbing the light, and then matter creating another shell, electronic shell, and those shells are making the universe which we see. They are electron. They have some certain shapes. Those shapes make objects, chairs, humans, grass, trees, and all of the electron are made up of disconnected phases of energy. In between two phases, in between two energy shells, there is nothing, like you call it electron. It means that Asharians were right, because electrons are making seeable universe, and electrons are disconnected. Their existence is not proper. We can only tell about their probability, 90% probability, that either they are on the ground state, either they are, or they are on some excited state. In between those two states, they don't exist. It means that you have proven Asharian's view. And Asharian told that when you were standing on a point, and they are actually answering to Zeno, who said that in between 2 points there are infinitely small things, infinitely small points. You cannot count them from 1 to 2. But Asharians claimed that no, infinitely small indivisibility is impossible. This may be true in mathematics, but this is not true in the real world. In the real world, you have to limitize your length. So when you limitize your length, it is called Planckian length. And you say 10 to the minus 34. And this is what you do. from a point where you are standing in a space, you travel towards the other point, which is the next point, and on a point you're standing, it is a Planckian point. When you step forward in a Planckian time, in between those 2 points you don't exist. This is what quantum physics is telling you. This is not something which is maybe miraculous or maybe unbelievable, which I am telling you, not coming from me. This is what quantum physics tell you. This is what Asharians tell you. That is the reason I say that Asharians are the fathers of modern quantum physics. So this is how Iqbal objects Einstein's fourth coordinate. When he says you are putting the copies onto the same object, and you are putting those copies, and you accidentally, suddenly, you just gave up putting those copies in fourth coordinate. You were putting the copies of point, you created a line. You were putting the copies of lines, you created a two-dimensional object. You were putting the copies of two-dimensional object, you created a three-dimensional object. Now you are not putting the copies suddenly. You are just saying that this, Iqbal says, yes, Ouspensky's interpretation could be true. Just put the copies there. Copies exist. Copies exist by the law of quantum physics. So just put the copies there, and then you would see that there is no need for a pre-existing line. Why? Because if you are putting the copies and somehow those copies are disappearing, then why you would need a line? You need just a point. Disappearing copies coming, going, and appearing copies coming on that point. You stay in that point. There is no need of a line. That's why I always draw Iqbal's time like this. Look at here. This is my vision of Iqbal's time alongside Einstein's time. You can see that Iqbal's point of view, Einstein's point of view on the same slide. So how I express it according to my understanding, you can see right now when I click the next slide, and you will immediately know that what I have done here. Look at this. That's what I did. Let me show you again. These 3 or 4 slides, you should look at those slides. The right side says Einstein's point of view, which necessitates a line perfectly drawn before the existence of the object, before the existence of a new copy. And now on the second side, you see there was needed a line, but Iqbal did not think of that line. And then I am envisioning is this line here. In that manner, first copy created, started time. Next copy, time is with that copy going upwards. Next copy, meaning time is created by the existence of the object. And this is very, very, very important thing here. The crux of my lecture, the gist of my lecture, everything of my lecture is now in coming 2-3 sentences. It's that. But before I give you the gist, I will give you another evidence of all of my argument. Another evidence, a physical one. And you will be happy to hear that evidence. What is that? Big Bang theory. Big Bang theory suggests that as soon as time started, as soon as first particle, the energy content of the first particle started to inflate, the first particle, maybe some people say that was a spring, maybe some say that was a white hole, that was a very tiny particle, even smaller than Planckian maybe length. But let's say that it is impossible to divide more than Planckian length. So we imagine that that was a Planckian length. Okay. So a Planckian sized particle was in the beginning, and then that particle started inflating and universe came into the existence. Okay, this is called Big Bang theory, right? Okay. Now, this is the evidence I am giving you. The first string started to inflate. As soon as it started to inflate, time started with it. It is not what Einstein says. Do you think that before the Big Bang time was there? Nobody believes it. Everybody in even science says this is the evidence of all of my talk. Everybody, even in science, they say as soon as first particle with its energy content started to inflate, time started with it. So this is what Iqbal's time is. Iqbal's time is like a bud. It starts with objects. It is like a bud and it grows like a branch in the cosmic tree of probabilities. Iqbal time is like a bud and it grows like a branch in the cosmic tree of probabilities. This is my quote. Okay, so Iqbal says, and this is what you keep with you, and this is what's your takeaway. This is that as soon as an object exists, time starts with it. Not only the Big Bang theory suggests it, but for every object, Iqbal believes is the same case. With the existence of an object, its time starts. With the when the existence of an object is seized, as soon as it is seized, its time ends at that time. Iqbal time is something different. Iqbal's time starts with the object's life, and that's where he differed with Bergson. I have already told you that Bergson believed that time dominates self, but Iqbal says that no. If you believe that time dominates self, it would mean that time existed before the existence of the object. That's impossible. Time can exist only after the existence of the object, as Big Bang theory tells us. Okay, so time exists after the existence of the object, meaning, let me change the word object with the word being, because we are objects, but we are now conscious beings. So let me for a moment change the word object and replace it with the word being. Okay, so if you believe in Einstein's time, you would say time existed before the being, which in other words you are saying time existed before the God. This is what you are saying, that it means that universe has a continuous pattern, as I have shown you in the beginning. Universe has a continuous pattern with infinite beginning, with infinite eternal end. That is something not acceptable after the Big Bang for scientists even. And it is, how ironic is this? Sometimes I think, how ironic is this that Einstein gave us general theory. Einstein gave us the equations of general theory, which is called the field equations, and the same field equations were used in order to create the Big Bang theory, and Big Bang theory came along and it demolished Einstein's time fourth dimension. And it demolished it. It said, no, as soon as objects starts to exist, its time starts to exist. As soon as an object ends to exist, its time ends to exist. As an object grows like the arrow of time, of entropy, as soon as an object grows like a social being, we social beings, we grow in our probabilities tree, its time grows. You can even control your time. Time is very precious for Iqbal, but time doesn't come before the self. Time doesn't come before the existence of God. So that's where he differs with Bergson. That's where he says that Bergson's saying that time dominates self is wrong. He says self dominates time. God was first and God created time later. So that's where I will end my talk. But I hope that someday, another day, I will come here and I will complete it with the help of quantum physics. But that is another topic. This topic was Einstein's space-time and Iqbal's objection on that. And I think I have done a little effort. Thank you very much. Yes. Yes, exactly. You. Yes, exactly. Quantum physics is saying the same thing, that space and time both are emergent properties. Actually, this confusion starts when you say that as a point exists in a line, a 3D object must exist in time. Iqbal corrects it. Iqbal says no. As increasing point create more line, increasing 3D objects will create more timeline. That's a very simple difference. It's very interesting and beautiful difference. So this is where we differ. Thank you very much.